किधर है, देखिए जरा। फुल स्क्रीन कौन सा है?
सर इस पर प्ले करो,
ये वाला। Good afternoon, everyone. Let me start the session today. Today's topic is on statistical issues in clinical trial. You all have been already explained what are the various study designs. There are two kinds of study designs: observational studies and intervention studies. Observational studies are cross-sectional, case control and cohort, and intervention studies are also known as clinical trial. So in clinical trial you give some intervention and try to see the effect of that intervention as compared to usually standard of care. So that is what is clinical trial. You are intervening and trying to see the effect of intervention on some outcome. Whatever vaccines, whatever drugs, whatever diagnostic methods, all of them are there because they all have undergone clinical trial. Clinical trial have different phases. You all have been told about it: phase 1, phase 2, phase 3, phase 4. So in phase 3 and phase 4, even in phase 2, what are the statistical issues involved? That is what is the topic of discussion today. Broadly, three aspects are important from a statistical viewpoint. One is the sample size. So whenever one is planning a clinical trial to evaluate an intervention against the standard of care, one would like to know as to how many patients I should take, how many patients I should enroll in my study, because the number of patients that are enrolled in a study would have implication on duration of study, cost of study, manpower. A whole lot of issues will be there linked to the number of participants or the patients that the investigator enrolls in the study. So sample size is an issue. Also, if you are reading some results of some clinical trial, so before you accept the results of that clinical trial, you would like to know, you would like to be sure that whether this person had or this study had adequate sample size, or is it less than what is actually he or she should have taken. So sample size is an issue in clinical trial. Sample size is an issue in all studies, whether clinical trial or observational, but so sample size would be an issue in clinical trial. Second statistical aspect that is important in clinical trial is randomization. So if you do an observational study, so then you will be taking participants through some sampling procedure. Here randomization is that if a participant or a patient comes to you, then how do you allocate, how do you decide whether he gets new intervention or he gets a standard of care, right? So the criteria for deciding, or the principle for deciding, or principles for allocating this participant in any of the two groups is done based on methods of randomization, because this participant should have an equal chance of being allocated in any of the two groups. So there are methods for doing randomization. Why we do randomization, we'll discuss that. So that is second part. And third part is analysis and presentation of results. So sample size will be an issue in all studies. Randomization will be an issue in clinical trial. If you are doing an observational study, then not randomization, then random sampling will be the issue. And analysis and presentation will be an issue in any study, whether it is clinical trial or whether it is non-clinical or whether it is observational studies. So we'll discuss broadly these 3 points: sample size, randomization, and analysis and presentation of results. Sample size is an issue at two stages. One, at the design stage, as I explained to you, how many subjects are necessary to estimate a parameter. Second is interpretation stage. If you are reading somebody's results, you would like to know is it adequate or not. Now, what are the implications of a small sample size, and also what are the implications of large sample size? So you may say that I will do a trial, but the number of patients that I will take is actually based on my convenience. in 1 year time whatever patients I get, I will enroll them. That's as per your constraints. Or you say, no, I have only 2 kids, and in 2 kids I can do 60 tests, so I will enroll 60 tests, right? So n has to be actually decided, n has to be actually calculated. So if n is too small, then even the small effects you may miss, like small effects you may miss, right? So many studies, what they do is they don't calculate sample size, they do a study trials on very small number of patients, and they say we are doing a pilot study. So there is nothing like pilot study. Those are basically feasibility studies. Pilot studies are basically feasibility studies, and feasibility studies you just try out your methods, you don't draw conclusions out of your study. So these are the implications of a clinical trial having small n, or for that matter even observational studies having small n. If your n is too large, if you enroll number of patients more than what is actually required, then the study will obviously be more difficult and costly, and also the results will come later than when it should have come, right? Also it is waste of resources. Why you want to enroll more number of patients than actually required, right? And also more data. So there is inverse relationship between volume of data and quality of data. More data you collect given the same level of resources, your quality of data will be poor. So one should collect less, one should collect only that much data what is actually required. So n having small sample size has implication, having large sample size also has implication. So therefore one should calculate sample size, and sample size is calculated for your primary outcome. So I'll just show you some examples as to how sample size is calculated. So let us say you are doing a clinic, somebody is doing a clinical trial. You have two groups. Group 1 is your standard of care, group 2 is your intervention or the test group, and your outcome is quantitative. Then you will have mean and SD for the quantitative variable. So if somebody is planning a clinical trial and he comes to me asking that how many patients do I require to enroll in each of the two groups, so then I will ask him, tell me the anticipated mean SD in the two groups. So he tells me anticipated mean SD, and there is a simple formula that we use and we calculate the sample size. So this is an example. Nutritionists wish to study the effect of lowering sodium in diet on systolic blood pressure. During a pilot study, what they observed was that the standard deviation of the systolic blood pressure with low sodium diet was 11.3, while with the high it was 13.3. Alpha is 0.0. Alpha is type 1 error that you have already been explained. Beta is type 2 error, and 1 minus beta is the power. So how many persons from each community should be studied? If you want to detect a difference of 3, that is what is the effect size. Difference of 3 means mean systolic blood pressure in the intervention arm and mean systolic blood pressure in the control arm. So the difference in mean is 3. So this is how same formula you use it and calculate, you get 347. So to calculate sample size, there are options. One is use this simple formula. Suppose you don't want to use this simple formula, then there are ready-made tables available. Now to see the table, you have to find out what is the standardized effect size. So your effect size is 3, SD is 12. So what would be the effect size if your SD is 1? So then 3 by 12. 3 by 12 is 0.25. So this is what is required if you want to see the table. So there is a table available. So in the table E by S, look at this is 0.25, and this is what is combination of alpha and beta. You get 336. Now this is what is the number of participants that you need to enroll in each of the two groups. So in your trial you have to enroll something like 762 patients, right? And these 762 patients are actually evaluable patients. They should be there till end of the study. If you think that during the follow-up 10% of the patients will drop out, then you better inflate this number by 10%. So enroll 10% more, so that even after losing 10% of patients during follow-up, you are left with what you had actually calculated. So calculated sample size is the number of evaluable patients, and this is number of patients to be enrolled per group, not the total, right? Another is, suppose your outcome is categorical, cure or no cure, then this is a formula you calculate, and then there is the example and you get 82. Same, suppose you find this very complicated, there are options available, you get the same number 82, right? So there are options available, you can use the table, you can calculate using simple formula, and you get the sample size. So this is what is basically the sample size. Now that was for the parallel trial. Now many times people do crossover trial. Crossover trial means again you have two groups, A versus B. Now patient allocated to one group receives second intervention in the second phase. So here patients are enrolled and they are randomized, and here what you randomize means you decide what he should get. So basically you are deciding not A or B, but you're deciding sequence. So sequence 1 he gets test first and then control later. Sequence 2 he gets control first and test later. So suppose you have 30 patients in sequence 1 and 30 in sequence 2. So 30 will get test first and then control later, and these 30 will get control first and test later. So in both test and control you actually have 60-60, right? You have 60-60. So every person becomes like his or her own control. So crossover study designs, sample size requirement is 1/4 of the parallel study design. So there is an example, and just see here, you get 30 here, but if you do crossover then you get four times. So that was for crossover, and if you do parallel then you would need 122 subjects. So this is just to tell you that how sample size, what is the importance of sample size and how sample size is calculated. Next part is randomization. Randomization is a way of allocation. Randomization is a way of allocation. Why randomization is required? Why randomization is required? We are in the era of evidence-based medicine, and for that there is the hierarchy of the level of evidence that is generated from studies, right? And highest level comes from clinical trial. Highest level comes from clinical trial, randomized clinical trial, right? Randomized clinical trial. So if a trial is randomized, if there are two trials, one is randomized, other one is non-randomized, then randomized one comes at a higher level of evidence. Why do you randomize? You randomize for three reasons. Number one, because clinical trial is sample of convenience. So for example, if somebody does a clinical trial at AIIMS in our institute, so what he will do? He will sit in his clinic and he will enroll patients, whoever comes to that clinic, right? So he will have list of inclusion criteria, exclusion criteria, and if a patient fits into the criteria, then he will take consent, and then he enrolls in the study. So that way, whatever patients are enrolled in the study, they are not representative of all such patients in the population, right? Because everybody in the population does not come to AIIMS. It's a referral hospital. So all maybe complicated cases they come here. So the patients we get in AIIMS, they are not representative of all such patients in the population, right? So this is sample of convenience, right? So, and since all statistical methods that are used, their assumption is random sample. So therefore, unless you do randomization, you cannot use statistical methods where assumption is random sample. That is one reason. Second is clinical trial has to be like a football match. Like you have two groups, two teams A and B, and in both the teams everything should be similar. Everything should be similar except the skill of the team. No team, none of the two teams should have advantage or disadvantage with respect to the outcome, which is number of goals, right? So in a football match, anything which can influence number of goals, that is balance in the two groups. Maybe number of players, maybe width of the goal post, maybe size of the ground, maybe evenness of the ground, everything, maybe gender of the player, maybe age group of the player, everything, whatever you can think of can influence the outcome, that is number of goals. Outcome is something that is compared between the two groups to decide A is better or B is better. So here in football match, outcome is goal, because if one team scores 4 goal, other team scores 2 goal, so then outcome is compared 4 minus 2. So the one who gets positive plus 2, so that is the winner. So that is That is so second purpose of randomization is, if you do randomization, then many of the known and unknown other characteristics which are known as confounders are equally distributed in the two groups, likely to be equally distributed in the two groups, right? So that is the second reason. So first one was basically uh, first one was basically making sure that statistical principles are applicable. Second is known unknown confounders are comparable. And number three is allocation bias, because a clinician does a clinical trial when he is convinced that my drug is better than the control. So then he will have temptation to enroll patients who are likely to benefit from his intervention, right? So that is allocation bias. So to safeguard from allocation bias, randomization is done. So randomization is done for three reasons: to safeguard from allocation bias, to have equal distribution of other factors in the two groups, and then third one is to fulfill assumptions of statistical methods. So randomization, control group is necessary in clinical trial. How do you form the control group? Best way is randomization. So randomization is also called random allocation, right? So randomization is a process by which each participant has the same chance of being assigned to any of the two groups. It is something like equal to tossing of a coin. A patient comes to you, you toss a coin, head you go this left side, right you go to other arm, right? So same thing is done, but not by tossing coin, but using a computer generated random numbers. That is what is basically randomization. So there is a difference between randomization and random sampling. Randomization means you have population of interest, you have consenting eligible patients, and you randomize them into group A or B. Random sampling means you have population and draw a random sample, right? So randomization is a way of allocation and random sampling is a way of selection. So that is the difference between randomization and random sampling. Randomization is so there is no confusion between random selection and randomization. So how do we randomize? There are several methods available: coin tossing, random number tables, serially numbered opaque envelopes, computer randomization. So these are done. Why do we randomize? To create two groups which are prognostically similar. That means all other factors should be similarly distributed in two groups. So if you do randomization and if there were 50 females in your that you have enrolled, then you are likely to have 20 female in group A and 20 female in group B. If there were 40 old persons, then you are likely to have distribution of old persons 20-20. 80 diabetic patients, so you are likely to have 40 diabetic in group A, 40 diabetic in group B. So this is what it makes, it balances, because if it is not balanced, then they would become the kind of reason for explaining the difference in observed result, right? So this happens because each subject has an equal chance of being allocated to group A or B. This divides all the characteristics, measured or even non-measured, because there are many factors which we do not know. So they also get divided equally in the two arms of the study. There are methods of randomization. Broadly, they are classified as fixed allocation randomization and adaptive randomization. In fixed allocation, basically this procedure assigns the intervention to participants with a pre-specified probability, right? Many times it is 1:1, 1 to intervention, 1 to control. But many times control group is allocated 1, and in the intervention arm, two patients are allocated. Why? Because you would like to know more about the new intervention. What are the toxic results? What are the side effects? Because not much is known about the new intervention. Control or standard of care, you may know a lot of things. So that is why you enroll more patients in the intervention arm. And there are various sub-classifications: simple randomization, block randomization, stratified randomization. So I have just some examples of what is simple randomization, what is block randomization, what is stratified. Simple randomization is the most elementary form of randomization, also referred to as complete randomization. It is something like tossing of a coin. It approximately divides participants into two equal groups. For small studies, you can prefer a random number producing algorithm. It's very easy to implement. But disadvantage is, because if your numbers are small, you are likely to get imbalance in the two groups. So this is your random number table. This is your random number table, and see you can if your number of participants are in 2 digit, then you select random number. So I may select randomly, let's say first number is 20, then go down, go and selecting the subsequent numbers, then come up, or I may go horizontally. So you may decide before moving in one direction. Take one example. How do we prepare a simple randomization scheme? Suppose I have my n is 10. I have 10 patients and I want to allocate 5 into group 1 and equal number in group B. Then 10 number means 0 to 9. 0 to 9 are 10. So I may decide that if my random number selected is between 0 to 4, then I'll assign that patient to group A. If it is 5 to 9, I'll assign to B, because these are 5 numbers, these are 5 numbers, right? So go to your table. So you have 10 patients and these are the random numbers. First was 9. So since it is 9 is between 5 to 9, so goes to B. 1 is between 0 to 4, goes to A. 5 is between 5 to 9, goes to B. And like 2 is between 0 to 4, goes to A. So that is what is group allocation. So that is simple randomization. Second is block randomization. Block randomization is, suppose I have two groups. In each of the two groups I have 100, right? So then I may decide so 100 means 200. So I may decide 20 blocks of size 10 each. So first block of size 10, so in that 10 I will do randomization. So 5 go to A, 5 go to B. Next 10, 5 go to A, 5 go to B. So like that. So within each blocks I will do simple randomization. So that is block randomization. Many times people do block randomization with variable block size. Anyway, that I am not going to discuss. So this procedure is repeated for consecutive blocks. One may write down all ways of arranging the groups, and so let us take an example of this. Suppose my block size is 4. If my block size is 4, so there are 6 possible combinations: AA, BB, AB, AB, BA, AB, BA, BA, BB, AA, AB, BA. Now I can number them 1, 2, 3, 4, 5, 6. So 6 combinations. So go there here. Now the correspond, suppose first number is A. The number that randomly selected is 1. So since 1, so these 4 are already selected. That means if the 1, then patient number 1 will go to A, patient number 2 will go to A, patient number 3 will go to B, patient number 4 will go to B. So because this block size is 4, so that is how it is basically allocated, right? So random number 2, these are the 4, random number 3, these are the 4, because that is what is the combination, right? Stratified randomization is done for within each strata of confounders. Let me go to example. Example is somebody was doing a trial comparing zinc with placebo in newborns. So they created 1, 2, 3, 4 strata, and this strata is 3 to 12 months and weight for height like this. So different strata, and within each strata they generated a list of random numbers A versus B. So that is what it is. So strata 1, then allocation A versus B, strata 2 A versus B, strata 3 A versus B, strata 4 A versus B, and finally they analyze A versus B. So that was basically the randomization. How do you analyze a clinical trial? In a clinical trial, first thing that one has to report is the study profile or the trial profile. Trial profile means how many patients did you screen? Right? So this is just an example. In that study they screened 230 patients. Now, but all 230 were not eligible to be included because they had some inclusion criteria, some exclusion criteria. Their exclusion criteria was they were not going to enroll patients who are likely to move out of the study area in near future, because they were supposed to come back for follow-up. So somebody who is likely to move is not going to come back, so there will be dropout, right? So to minimize dropout, they said that we will not include any patient who is likely to move out from the study area. So there were 12 such patients. So even though they were eligible, but since they were likely to drop out or not come back for follow-up, so they were not included. Similarly, some patients, they were eligible, but they said no, they will not participate in the study for whatever personal reasons, right? And there are two patients, they are severely ill. So basically, maybe these two patients, their risk of death was very high, or maybe their conditions were not such where you could actually do the study or do the test in them. So these 12 plus 8 plus 2 are 22. So these 22 patients were excluded from the study. So 230 minus 22 is 208. So 208 patients were actually enrolled in the study, and they were randomized in 1:1 ratio to 104 for the intervention arm, 104 for the control arm. And when they started following these patients, so there will be loss to follow up in both the groups, right? Both the groups. So you have to give detail of the reasons for loss to follow up. One patient died. One patient, he moved out of the area, even though he had said in the beginning that he will not move, but still he moved out of the area for whatever reason. Maybe he got transfer order later or whatever. Refused further participants because he initially he agreed, but later he may have some his own reasons for refusal to participate in the study. So these are the ones. So you are left with 87 here and 91 here. So 87 patients and 91 here, right? So that is what is the study flow chart. So study flow chart has to be provided so that the reader knows how your study progressed. Also, you are supposed to mention that what all parameters you measured at what time point. So this is 0 time point, then maybe 3 months, maybe 6 months, maybe 12 months. So at different time points, what all was measured. So that also should be reflected in your trial profile, or this is also called study flow chart. So if you, for clinical trial, if there is something called consort guideline. So consort guideline is two part. One is the consort flow chart, second is the consort checklist. So this is consort flow chart, right? And when you do the analysis, there are two kinds of analysis which are done for intention to for clinical trial. So first analysis, before these two analyses, your first analysis has to be in any study describe the profile of your study subjects. Because when you submit your report, submit your paper, you don't attach your master chart or Excel sheet or bunch of study pro forma, right? So therefore the first table has to be describing the profile of study subjects for any study. So if you have two groups here, then in A, what was the mean age? In B, what was the mean age? What percentage were males in A? What percentage were males in B? And what are the various clinical characteristics between A and B? So that is what has to be reported in table number 1. Clinical trial, you can have more than two groups, right? But just for the simplicity, we are mentioning two groups. So first table is that. Second analysis has to be to compare primary outcome between the two groups and the secondary outcomes between the two groups. That is what is done. So all clinical trial, two analysis done at two levels. One is the profile of the study subjects in the two groups, and second, you compare outcome and compare the primary outcome and the secondary outcome between the two arms. So in your first analysis, when you're comparing the characteristics at enrollment, if there is any imbalance between the two groups, and if you think that this imbalance can impact your outcome, then this becomes confounder, and then you need to adjust your effect size, that means difference in the outcome between the two groups for these confounders, right? So there are two kinds of analysis again. One is intention to treat and second is per protocol analysis. Intention to treat is the difference between intention to treat and per protocol analysis is in the denominator. In intention to treat, all participants who have been randomized, they will be in the denominator regardless of whether they have remained in the study or they have dropped out. So dropped out also are included in the analysis of intention to treat, whereas per protocol only those patients are included in the analysis who have adhered to the protocol. And in your protocol, you had mentioned that the participant will be there till end of the study. So anyone who violates protocol will not be included in per protocol analysis. So in per protocol, your denominator, your n, would always be less than the n for intention to treat analysis. Right? Intention to treat analysis tells you that how your intervention will work in real world situation, because in real world people will drop out, in real world there will be dropouts, people will miss taking tablets, right? But in per protocol analysis, you are assessing the true effectiveness or true efficacy of your intervention, that is what is a per protocol analysis. The results of per protocol analysis would always be better than intention to treat analysis, right? Intention to treat analysis, because true potential would always be more than what is actually observed at the ground level, right? Say for example, if you want to buy a car, so they will advertise that my car gives 21 kilometers per liter, but the same car, when it comes on the road, it will never give 21 kilometer. That is a real world situation, right? So when they did that, when they reported 21, that is per protocol, that is under ideal condition. That means showroom, air condition, constant speed, no red light, no buffaloes, no cow, no auto rickshaw. That is ideal condition. But the same car, when it comes on road, it doesn't give the same mileage. So intention to treat tells you effectiveness, how it will work in the true world situation, and per protocol tells you the true potential of that intervention, right? So per protocol analysis are basically efficacy, and efficacy is difficult. To know the efficacy, you must ensure 100% compliance to the protocol, adherence to the protocol. So there are two analyses: intention to treat and per protocol analysis. Now just see this example. This is a trial of drug M for migraine. There are two groups, treatment and control. So what calculations you do for study on clinical trial? What are the summary measures that you calculate? You have two groups, treatment and control group. In treatment you have 100. So total patients enrolled were 200, and these 200 were randomly divided based on randomization. They were divided into treatment group and control group. So 100 went to treatment group and 100 went to control group. Their outcome was recurrence. So these patients, they are the ones who had completed treatment. They became all right, and then you started following them for recurrence of the outcome. So in the treatment group, 5 patients recurred, whereas in the control arm 30 recurred. So that is what is the outcome. So what do you calculate? First is one will calculate risk of recurrence. So what percentage of patients they recurred in treatment group? 5 upon 100, that is 0.05. That is risk of recurrence. What is the risk of recurrence in this? 30 upon 100, 0.30. So this is what is summary measure in group A and summary measure in group B. But then you have to compare the two. So to compare the two, you will calculate relative risk. That means 0.05 divided by 0.3, which is 0.17. What does it mean? It means that if you give treatment M to a patient, then his chances of recurrence comes down by 83%. So for a patient who is in the control arm, and if his chances of recurrence is 100, then by giving treatment you are taking away 80% of chances of recurrence. That is what is 0.17. This is known as relative risk or risk ratio, or the ratio of two risks. So that is one measure that is calculated for clinical trial. Second that is calculated is basically relative risk reduction. So that is same thing I said, 1 minus 0.17. So how much risk is reduced? It is 83%. 83% risk is reduced. So if the risk of recurrence is 100 in control arm then 83% of the risk is actually reduced by giving this intervention. So relative risk reduction. Another thing that you calculate is what is the absolute risk reduction. What is the absolute risk reduction? So here risk was 0.30 and 0.30, how much it has reduced to 0.05. So that means 0.25. 0.30 minus 0.05 is 0.25, that is absolute risk reduction. The number needed to treat is 1 upon absolute risk reduction, that means 1 upon 0.24, that is 4. That means 4 patients needs to be treated with this drug M to avoid one recurrence, one adverse event, one recurrence. That is what is number needed to treat. Then you can also calculate odds. Odds is 0.053. Odds is basically, odds is 0.053. So what is the, so 5 upon 100, that's the risk. So odds will be 5 upon 95. Here it will be 30 upon 70. 30 upon 70 will be 0.3. 5 upon 95 will be 0.053. That is odds in the two group, and the ratio of the two will be the odds ratio. 0.05 divided by 0.43 is 0.12. Right? So this is basically the odds ratio. So for a clinical trial, mainly you compare these summary measures. Now, just another example, there was a study where 2500 were randomized to two groups, vaccine and placebo, in 1:1 ratio. Now, in them, see, 1800 received 3 doses. They were supposed to get, all 2500 were supposed to receive 3 doses. However, not all received. So, out of 2500, only 1800 received 3 doses. As per the protocol, all 2500 were supposed to receive, but only 1800 received, 800 in the vaccine arm and 1000 in the placebo arm. So out of 1250 allocated to vaccine, only 800 received what they were supposed to receive. And in this, out of 1250, 1000 received. Now then 400 received 2 doses. 400 received 2 doses, 300 received only 1 dose. Right? So this is what it is. So intention to treat analysis when you do, then outcome has to be in all 2500. Intention to treat, your outcome has to be compared in all the patients who were randomized, regardless of whether what intervention they received. Right? So this is essential for clinical or public health policy, because you want to know not that what happens in the hospital, but you want to know what happens actually in the population. Per protocol analysis, outcome only in those who adhere to the protocol, and protocol had said 3 doses. So in per protocol, one would analyze only 1800 patients. Right? This is only for explanatory purpose. This is an academic exercise. Right? What is effect size? Effect size is nothing but the difference in the two groups, difference in the two groups outcome rate. So this is what is the effect size. Calculate like this. Then you have to calculate for each of the effect size, for each of the outcome measure, whether risk difference or risk ratio or odds ratio or number needed to treat, one has to calculate confidence interval. Confidence interval, that means you would say that when I did my study, I got relative risk of 0.6. That means if I give intervention, 40% of the risk is taken away. So this is in one study. So then you have to tell that if I do the study 100 times, in 95 of the studies, this is what would be the relative risk. So that means you are supposed to provide range of results that you are likely to get 95% of the times. That is what is the confidence interval. And then also you are supposed to report p-value. And that means, what does that mean? That you have to report that how often the results that you have got could be a chance finding. Right? So suppose your p-value is 0.04, so you would conclude treatment is better than control, but then 4% of times this may be purely due to chance. So that is what is the p-value that you have to report. Right? So this you have to report both confidence interval and the p-value. interpreting a study, so basically you have to see the internal validity. Internal validity we have to see, and then internal validity would depend on what are the possible biases that you have seen. Are the findings reported likely to be true for the trial subjects, right? So that means you have to make sure that there are no biases. You have to make sure that you have done proper analysis. That means there are no confounders. So that is what is internal validity. So if your study lacks internal validity, then forget about external validity. Internal validity is whatever you are reporting, is it true for your sample or not, true for your studies or not, right? That is internal validity. External validity is based on this, can you extrapolate to your target population? That is what is external validity. And to do this, then they would assess all the method section. Was randomization proper? Also, what blinding is basically to avoid bias. So what was the method of blinding? What was the method of ensuring that blinding is actually adhered, right? And then what was the follow-up? What was the follow-up? And what was the loss to follow-up? Because if a study has more loss to follow-up, then the internal validity is not good. Because in a clinical trial, those who are lost to follow-up, that means they did not come back to you for follow-up. And you don't know why they did not come back. It may be that your intervention was very beneficial, so they thought that if it is beneficial, why to go to hospital? Or maybe your intervention had lot of side effects, so they said, why to go to hospital? Because just this drug is giving lot of side effects, I'll go to some other place, not to AIIMS. So you do not know why they did not come for loss to follow up. So having large loss to follow up is not good for the trial. In any trial where loss to follow up is more than 20%, the results of that trial is not taken very seriously. Then they will assess whether intention to treat analysis was performed or not performed, right? So generalizability they will assess based on what is study site, what is the setting, how were the subjects identified for screening, what was the inclusion exclusion criteria, and in what kind of subjects was the study conducted, findings are applicable for similar population or not, right? So internal validity is a prerequisite. That means your result has to be true for the sample that you have studied. If your result is not true for the sample you have studied, then forget about generalizing results to population, right? So internal validity is prerequisite for this, for clinical trial. Interpretation of negative studies. Many trials, they do not calculate sample size properly. They take less number of participants than actually required, and they don't find the difference. And once they don't find the difference, they say there is no difference, right? Absence of proof is not proof of absence. So if you have not been able to find something, it does not mean it does not exist. Maybe your study did not have that kind of edge, that kind of power to pick up such small effects. That small effect was lying there, but you just missed it. So something, if it is not there, does not mean it is not there, right? Then one would assess your ability to detect that size of effect size, right? Finally, in any trial or in any analytic study, when you show there is a relationship between exposure and outcome, drug and cure, there are four possibilities. One possibility is it could be due to bias. So when you report A is better than B, then you have to convince other person that bias is not the possible explanation of what I am saying. Second is you have to convince the other person that other factors are not the reason of what I am saying, right? And then you have to say that you have studied a sample and my sample size was adequate. Sample size was adequate for the results that I am reporting, right? So chance, I have not got the result just due to chance. So once you rule out the role of these three, then only you say that my results are real. Association is real. So this is what is basically in very quick sense a clinical trial. So if you have any question, we can take that.